Dear students, we are going to learn some questions, answers and explanation on gas laws. The first question is write about physical properties of gases. The gases are characterized by these physical properties. Gases have high compressibility. What is that? What is compressibility? When you apply pressure on gas, the volume is decreased more when compared to the solids and liquids. So, they have high compressibility. Similarly, they exert pressure in all directions equally, because the gases randomly moves in all directions and impacts or bombards the walls equally. So, the pressure is also equal in all directions. Gases have much lower density than the solids and liquids. Gases have less density. Why it has less? Why they have less density? What is density? Density is nothing but the number of molecules present in unit volume. In solids, the number of molecules are more in unit volume because they are closely packed, whereas in the liquids the molecules are somewhat less when compared to the solids in the unit volume, whereas in the gases the number of molecules are very less in unit volume because the distance between the molecules are more. So, number of molecules present in unit volume are very less. So, their densities are very less. That is a characteristic property of gases. The volume and shape occupies of gases are the same as shape of the container, what they present, what are they existed in that particular vessel. For example, you take gases in a glass jar, it has a shape of glass jar. In bottle, it has a bottle shaped gas. So, the shape depends on the container where it is present. They undergo diffusion. What is meant by diffusion? Diffusion is nothing but intermixing of two or more gases completely one into the other, irrespective of gravitational force. You know, in kinetic theory, there is no gravitational force on the gaseous molecules. So, the mixing up of two or more gases completely one into the other, that phenomena, that process is known as diffusion. The gases has a special property of diffusion, whereas solids and liquids they do not have such property. Now, gas laws. What are gas laws? What are the special properties? Tell me some gas laws. You know, gases have some special properties, or they are measurable properties. What are these? What are they? Volume. Volume can be measured in CGS units centimeter square, where a centimeter cube cc, or in SI units meter cube, that is liters. Liters, that is meter cube, you can write. The pressure is exerted by the gas P. P is the CGS units, the pressure is expressed in dynes per centimeter square, whereas in SI units the pressure is expressed in newtons per meter square. Newtons per meter square. What is the relation between this Newton per meter square, 1 Newton per meter square with the dynes? That is 1 Newton per meter square is equal to 10 dynes per meter square. So, these are the next one is absolute temperature. Absolute, what is the difference between temperature and absolute centigrade temperature and absolute temperature? Centigrade temperature plus 273 gives absolute temperature. So, if you know the gaseous temperature at a centigrade, you can convert that into absolute temperature. For example, a gas is at 27 degrees centigrade room temperature, at room temperature. that is 27 degrees centigrade. How can you convert that into absolute scale? 27 plus 273, that is 300 degrees Kelvin or 300 degrees absolute. So, that is the temperature. Generally sometimes you can express in a centigrade scale also, but most of the times in problems and narrations generally we used to express that into absolute scale. Those gases gaseous temperature is expressed in a absolute scale. Next one is the amount of gaseous substance. Gases are the mass of the gas is expressed in number of moles. What is mole? Mole is nothing but molecular weight by gram molecular weight. Molecular weight divided by gram molecular weight. For example, some 8 grams of oxygen is taken, 8 by 32, molecular weight is 32 for oxygen molecules. So, 8 by 30, 1 by 4 is the number of moles. On these 4 variables, so many you can generate 4 laws. 4 variables can give 4 laws. See, let us see. If you fix, if you take 2 variables fixed and see the relation between the other 2 variables, that gives one law. For example, standard at constant temperature and mass. Mass is fixed mass, moles are constant and temperature constant. These 2 are constant, 2 variables are constant. The relation between P and V, P inversely proportional to V, P is equal to 1 by V, sorry, P is equal to K by V. So, it's a P, if you increase P, the volume is decreased. If you decrease P, volume is increased. The relation between P and V is inversely proportionality. That relation is called Boyle's law. So, one law it is. If you take constant temperature and this one, what is that? Constant pressure and fixed mass, then you will get Charles law. The V and T, the remaining are V and T. The relation between V and T is nothing but V directly proportional to T, volume directly proportional to absolute temperature. Another law can be that is Charles law, you can say. Another law can be generated. If you take the volume and the mass are constant, volume and mass moles are constant, then what are the remaining? P and T. The relation between P and T, P directly proportional to T. As the temperature increases, pressure increases, temperature decreases, pressure decreases. So, that relation is called proportionality, directly proportionality. That gives Gaseous law, that is nothing but Gaseous law. Another one is P and T are constant. P and T are constant. What are the variables remained? V and N. The V directly proportional to N, V directly proportional to N. That is Avogadro's law. That means out of 4 variables, you take 2 variables fixed and see the relationship of the other 2, then that gives one law. So, 4 variables you will get 4 laws. What are they? What are the those gas laws? Boyle's law, Charles law, Gaseous law, Avogadro's law. Boyle's law, Charles law, Gaseous law, Avogadro's law. Next question, state Boyle's law, give mathematical expression. At constant temperature, volume of given gas, given fixed mass of gas, volume of fixed mass of gas inversely proportional to its pressure. V directly proportional to 1 by P, V inversely proportional to P. Volume increase, when volume is increased, pressure is decreased. When volume is decreased, pressure increased. Volume is increased to 2 times, pressure is decreased to half. That is the relation between V and P is inversely proportionality. at constant temperature and mass, V inversely proportional to P. V is equal to K by P, K is proportionality constant, that is Boyle's constant. PV is equal to K, PV is equal to K. So, this definition can be also written in this way. At constant temperature, given mass, the product of pressure and volume is constant for a given mass of a gas, So, volume, for example, another thing you see, at constant temperature for a fixed mass of a gas, in first state the volume is V1 and pressure is P1. These two are changed to undergo some expansion. The volume becomes V2, V1 becomes V2 and P1 becomes P2. So, by using this equation, P1 V1 is equal to constant in first stage, in second stage P2 V2 is equal to constant. So, if you equalize the same gas at same temperature, so P1 V1 is equal to P2 V2, that is equal to constant. P1 V1 is equal to P2 V2. This is another equation to do some problems on the Boyle's law. Now, what is isotherm? Graphs drawn at constant temperature between pressure and volume. Not only pressure and volume, any two variables, but you have to take at constant temperature, that relation. That is shown in graph, in the form of graph. You will get isotherm. The graph is called isotherm. So, for example, this Boyle's curve, that is pressure and volume. Pressure is taken y axis, on y axis, volume is on x axis. So, you see the relation, you will get a curve, that is called Boyle's curve. As it is drawn, this graph is drawn and the relation is drawn at constant temperature. So, this plot is a plot or graph, PLOT, plot or graph. This is called Boyle's curve or isotherm. Iso means equal, therm means temperature, equal temperature or constant temperature. So, isotherm, it is also called as Boyle's curve. It is also called as hyperbolic curve, Boyle's hyperbola. This is shape is a hyperbola, hyperbolic curve. So, next question is, at constant temperature, pressure of given mass of a gas is increased to 5 times. The mass is gaseous pressure is increased to 5 times. What happens in its volume? So, generally the relation is inversely proportional. It is 5 times increased, means the volume is decreased to 1/5. So, that can be calculated like this. So, P1 V1 is equal to P2 V2 relation. At initial stage, P1 is equal to P, let P1 is equal to P, V1 is equal to V. Similarly, at final stage, P2 is 5 times initial pressure. So, if it is increased to 5 times, so 5P. What is the volume at final stage V2 question mark? The relation is P1 V1 is equal to P2 V2. So, you want V2 is equal to P1 V1 by P2, PV by 5P, V2 is 5P, so 5P. P cancelled out, V by 5 you got. That means V is initial volume. It is V into 1 by 5, that is 1/5 of the volume decreased to 1/5 of the initial volume. This is the answer. Volume decreased to initial 1/5 of the initial volume when the pressure is increased to 5 times. Thank you. Please subscribe.